Nanotechnology is widely recognized as a key enabler to deliver products with unprecedented properties. The OPTINANOPRO project enhanced materials with nanoparticles dispersed in the material bulk or applied on the material's surface to deliver new competitive packaging, automotive and organic photovoltaic products. The initial nanoparticles introduction in liquid media can initially be done using high shear dispersion. Our consortium can provide open access pilot reactors for that purpose, as well as for nanoparticles functionalization. Alternatively, it can be done in solid state with high-energy ball milling to avoid the need for post-drying and to ensure nano safety when handling the materials. The pre-dispersion can then be processed by extrusion compounding in case of thermoplastics matrices, by coating or electrospray-on packaging and flexible solar cell surfaces. For multifunctional products, the different approaches can be combined. The project partners have open access pilot compounders and injection molders for the development of nano-enhanced formulations, which furthermore integrate ultrasound systems to optimize the nanofiller's dispersion. These nanocomposites compounds can be subsequently used to injection mold packaging and automotive parts. In terms of automotive sector, the project resulted in car parts with reduced weight but maintained structural performance and improved flame resistance. This can contribute to reduced fuel consumption and therefore lower greenhouse gases emissions. With support from an open access coating and lamination pilot plant, the project delivered barrier solutions with reduced gas permeability. Novel electrospray processes were developed to modulate polarity and generate superhydrophobic and amphiphobic surfaces. Tailored monitoring systems have been implemented in the coating and electrospray line for ensuring constant quality of the nano-enabled materials. In terms of packaging sector, these materials can be used in lighter packaging or for performance improvements in the sense of increased food shelf life and reduced food spoilage. In addition, optionally together with the barrier functions, the project produced easy emptying solutions to reduce cosmetics and pasty products residues at end of packaging life. Once more contributing to resource efficiency, such packaging will also be available to recycle or can even be composted at end of life when combining our nanotechnology toolbox with biodegradable materials. In terms of solar energy sector, we expect to decrease maintenance frequency and increase energy harvesting thanks to self-cleaning organic photovoltaic cells. In the project, a network of pilot and industrial production lines has been set up along the new supply and value chain to allow the integration of the developed formulations and processes. Needed innovation services, solutions and products are now available to allow deploying the huge market potential of our innovative and sustainable nano-enhanced solutions.